Okay, we're going to go over a technique for solving quadratic equations called the square root principle, which, surprise, surprise, involves taking a square root somewhere along the way in the equation. Now, I've got two examples here. So if your example looks like this top one, great. We'll do that one right now. If your example looks more like this next one that you're looking at, stick around or maybe zip forward in the video just a minute or two. I'll get to that one next. So what you want to do here is notice that I have isolated the square already, right? This thing, this guy right here, that 6k plus 3, that's the square. And there's nothing else going on in this equation. It's just something on the left side squared. So the very first thing I want to do is square root both sides. I'm going to square root the left and I'm going to square root the right. And that is going to form two equations down here. Okay, one of those equations is just going to be 6k plus 3 equals square root 45. And the other is going to be 6k plus 3 equals negative square root 45. And pay attention to that negative sign. That's what makes these two equations different. Now, I did actually make a mistake here. I wrote down square root 45 without simplifying that. And that wouldn't give you full credit if you wrote that. But we're going to take that plus and minus idea, and we're just going to put the simplified form of square root 45 here. If you think about what square root 45 is going to be, remember 45 breaks into 9 and 5. So this is really the square root of 9 times 5, which is 3 times 3 times 5. And those 3's pop out. So this is going to be 3 square root 5. So that's what I want you to write in here. 3 square root 5 instead of square root 45, and negative 3 square root 5. So step 1 is done. You now have two equations. And what you need to do in the next step, and I'll show this in green just so you can see, is we're going to minus 3 from each side. Okay, and here, I don't have room there, so I'm going to write it over here on the right margin. It's going to be 6k plus 3 equals 3 radical 5. I subtract the 3. I get 6k equals 3 radical 5 minus 3. And now I divide each side by 6. So that's 3 radical 5 minus 3 divided by 6. Make sure to simplify. So that's going to be radical 5 minus 1 divided by 2. And that's my answer for the left side. Radical 5 minus 1 divided by 2. Kind of ugly, I know. And you're going to make sure to watch out for the right side, which is a little bit different. If you go through the procedure on the right side, you'll see why there's only a negative sign on the radical and the rest of it stays the same. But I would suggest going through those steps so you don't make a mistake. Now, second example. This one looks a little simpler, and in some ways it is, because the square, although not isolated, is very, very simple. That's not the square, that's just a 2. The square is this k squared thing. If I can get k squared by itself, I'm practically done. So what I'm going to do is subtract 5 from both sides. And let's just write this over here now. That's going to be 2k squared equals negative 72. And now I'm going to divide each side by 2. So I get k squared equals negative 36. And now I'm going to take, again, the plus or minus square root of both sides. Okay, but before I get to that, we have to write that answer in here because it wants the equation isolated, but it doesn't want you to square root anything yet. So say k squared equals negative 36. And now we go ahead and plus or minus square root each side. It's going to give you two equations. One of them is going to be the square root of I times 36, which makes 6i. The other is going to be negative I times square root of 36, which means negative 6i. So those are your two answers, and you would write them in this way. 6i, comma, negative 6i. Now you're going to notice in this unit, sometimes the answer has I in it, and there's imaginary things because you square rooted a negative. Sometimes the answer is more like this top one, where the radical was kind of ugly and you had 45 and you had to simplify that one. And sometimes it comes out as just clean whole numbers, like your answer is 7, and that's great. But be aware of those differences. It doesn't mean you're wrong, it just means the problem was set up differently.